I'm gonna let them. I'm gonna let it be up there. Okay, now it's actually live. So there's the first six, and y'all got your pictures, right? Okay. 7 through 15. Can you see that okay? Or you can get that, and I'll move it up a little bit if you need me to. Good? Where's the last bit of 15, 14, and 15? And then last page.
So last night I had a little bit of an argument with somebody
Awesome.
about they put on their Snapchat story a tweet that said we should just replace Algebra 2 with classes that actually matter, that prepare us for the real world.
All right.
And I'm like, well, our school technically has classes like that.
Yeah.
Like, I'm sure yours did too.
And you just took the wrong one.
You just took them wrong. And he was like, there's no point in it because everyone fails the class anyway. And I'm like, okay, well, maybe at your
First
school.
of all, if you're failing Algebra 2.
Yeah, if you're failing Algebra 2, you need to not be in high school, I guess. But like, and he was like, we don't even use it in college. And I'm pretty sure he's like a theater major.
Well, you have to have college algebra.
Yeah, but
so.
like, other than that, he's not going to use,
Mhm.
So he's like, I don't even use it in college. And I'm like, well, some people actually like want to do math and have like reasonable careers that are actually like feasible,
Yeah.
unlike theater.
Yeah, where you can actually get a paying job.
Yeah. Without being a one
And
in a
if
million
he's
chance.
theater tech, then he does need a lot of
Yeah.
math. And I mean, you do. You need a lot of math for theater tech. But if you're theater performance, then you don't need math. You don't even need to know how to count because you're not going to make any money.
Unless you make it.
Wrong major.
Yeah. Yeah. Have you seen like all these people that are, and student loans are ridiculous and you need to make good choices, but people are like, I'm $50,000 in debt over school loans. You're like, well, what did you major in? And they're like, liberal arts. Okay, well then you're gonna be in debt.
Yeah.
Yeah.
I mean, my mom's still in debt and she did like speech pathology,
Yeah. Yeah. I got a degree in psychology.
I got a degree in sign language.
Yeah.
Just like something off the wall, like
Yes.
that you can't even.
Art appreciation. Oh yeah, people are really paying folks to appreciate their art. Anyway. Okay, well, but seriously though, like school loans are no joke. We talked about this already. Some people have to take out a loan. Okay, I understand. Like you have to take out a loan. Just be smart about it.
Yeah.
Like just because they're going to give you a whole lot of money. Because the more money they give you, the more money they make when you pay it back. So just be smart about it.
You just funnel it in as you need it.
Ooh, okay, thank you. All right, so makes me cry a little bit. Okay, f of x equals sine 3x. So what we're going to do is we're going to find the derivative and the antiderivative of the derivative. And there's a point, there's a pattern here. We're going to see at the bottom by pattern recognition. So there's a point to this. So if I wanted to find the derivative of this, that would be f prime of x equals, what's the derivative of sine? It's cosine. So we're going to take the derivative like of the mom and leave the baby alone times the derivative of the baby. So f prime of x would be 3 cosine 3x. I need to just go get that roll of tissue and just leave it next to me. That's what's fixing to happen right here. Mars Pie Day. You want me to bring some food for the three of you? Some round food?
You want to go in group chat?
We'll work it out. Hannah, was that letter what you needed? Okay. All right. So
No,
then,
it needs to be in German.
well, then put it through Google Translate. If you want the antiderivative of 3 cosine 3x dx, then that would be sine 3x plus c. So the derivative of e cosine x is e cosine x times, let's see, negative sign, yeah. So you've got f of x equals negative sine x.
Notice from calculus and none of that was even numbers, like
Mhm.
remotely numbers.
Yeah. Everything is just the symbol. I'm gonna sneeze again. Okay. If you want to find the derivative of this, this is being multiplied, right? That's a multiplication. We don't think back. We've done this. Oh, man. I can't remember where the notes are. What chapter or what page? But it's just going to end up being e cosine x plus c. I'll find it. I'm gonna write myself a note. Okay. Now this one, I don't think that we've talked about this one. I think I told you to learn it and memorize it. Do you remember this one? U prime over u. Do you remember that?
I had to use it yesterday
Oh, you did?
for homework.
Oh, okay. So f prime of x would be 2x over x squared plus 3. Antiderivative of 2x x plus 3 dx would be the natural log absolute value x squared plus 3 plus c. F prime of x on this should be negative 1/2 times 2x and turn into,
Would there be a 1/2 in front?
yeah, you're right. I just forgot to write it. Would turn into, so that's going to cancel. So it's going to be x over the square root of x squared plus 3. Because okay, so if this is the derivative, the antiderivative just takes you back to the original function. If this is the derivative, the antiderivative takes you back to the original function. This one's a little bit different because you have to, bless you, it has to be positive. So that one's a little bit different. Okay, so anti-differentiation by pattern recognition. So these are composite functions. So when you're taking the derivative, it's it's chain rule. You're taking the derivative of the outside and you leave the inside alone times the derivative of the inside. If you have this, if you recognize this within a function, if you recognize an inner function times its derivative, your answer is going to be f of gx plus c. This is called, this is what Sparks called it, a license to integrate. It has an actual name. I'll think of it in a minute. It's a rule. I'll give it to you in just a minute. So let's look at an example. I got a yellow pen that I set out for today. I wanted to highlight stuff. Here it is. Okay, so notice right here, you've got cosine 3x, and then you've got this 3 right there, right? So you've got this inside function, and then you've got the derivative of that inside function, right? Okay, so you would just change this to f of that inside function plus c. Okay, so for cosine, that's, get back in there, that's going to be sine of 3x plus c. If you look at this one, I've got this inside function of x squared plus 5, and then look what's outside. Got that derivative of the inside function, right? Got that 2x. Because what's the derivative of x squared plus 5? 2x, right? So I've got, that's there, all that's there. So what I'm going to write, I'm going to rewrite this. So I'm just going to take this right here, and I'm going to treat this like it's just its own thing. So that's going to be x squared plus 5 to the 4/3. And I'm running out of room, so instead of like divided by, I'm just going to put times 3/4 plus c. So that would be 3/4 x squared plus 5 4/3 plus c. On this one, do I have an inside function somewhere that has the outside's derivative somewhere? Yeah, where?
2x.
Yeah. And it's sticking around right here, right? So what's sine going to turn into? So it's going to be negative cosine 2x plus 3 plus c. This one's fun. Do you see something in its derivative somewhere?
The bottom one or the top one is the derivative of the bottom one.
Yeah, if you look here, it's the derivative of that.
So you use the natural log.
You're using the natural log. So that's natural log. And you got to use those bars, your absolute value bars, plus c. It's not too bad, right? You just have to be able to recognize what's what, where everything is. So what about this one? You see anything here? I don't see anything here, right? But I feel like I could.
Yeah.
Okay, let me show you what I can do. I can manipulate the system. Okay, what's the derivative of the inside? 3. So if I put a 3 right here, now I have it, right? But I changed the value of my integral. So what if I multiplied it by 1/3 out there? Did I change the value? Not anymore, right? Because what's 1/3 times 3? Close.
1.
It's 1 today. Tomorrow it might be 7. But today it's 1. Okay, so then you just do like you were just doing. Okay, so that cosine turns into what? So I'm going to have 1/3 sine 3x plus 2 plus c. And that's my answer. All right, we're going to mess with this one too, but we're going to make it work. Make it work. Was it Tim Gunn or something? Make it work.
So you multiply 1 on the outside by 2 and the inside by 3.
Outside by 2, inside by 3. The outside by 2.
Like, I don't know.
Well,
That makes sense.
I kind of think it does. Hang on. Let me rewrite this. Let me do that first. Okay, so the outside by 2. What do I need this to be?
You need that 2.
I need it to be 2x, right?
Yeah.
Okay. So
Do you
if I change this to 2x, what would I need to multiply by on the outside so that actually the value did not change? So that's like some algebra. That's like
Yeah.
like elementary algebra that you're never going to use in your whole entire life, remember? So here's what you want to do. You can say, what times 2 makes it 3? What times 2 would make it 3? I don't know. How could I figure that out?
You just divide.
Right? So that thing that needs to go on the outside is 3/2. So this needs to be 3/2. Now I haven't changed any values. I've just changed the look. I know that seems really elementary, but you have no idea how many calculus students will stare at that for like an hour because they forgot how to do a one-step equation because they're too busy doing calculus. Like a lot of times at this point in the year, you forget how to math because you've done all this other stuff, and then you're like, 7 plus 4 is 9. Like, no, it's not. It's not 9.
Do you blame us? Really,
No,
though?
I don't. That's what I'm saying. It happens every year. It happens every year. People forget how to math. It's okay. I get it.
See, I was getting there. I would have gotten there.
You would have
eventually.
gotten there. Yeah, you would have gotten there. Okay, so on this, now I have like an inside and an outside. So I'm good. So that's going to be 3/2, right? X squared plus 2. It's going to add 1 times 2/3 plus c. Hey, what's 3/2 times 2/3? Does everybody know why that 2/3 is there?
No.
Because I should be dividing by 3/2. Remember at the very beginning when you take the antiderivative and you add 1 and then you divide by that power? Well, look at that tiny little square. I don't have time to divide by 3/2, so I'm just putting a times 2/3 on the outside. That's why that 2/3 is there. Okay, so these two cancel out. And I'm left with just x plus 2 or 3/2 plus c. All right, so what about this one?
I mean, you could make it. You have to finagle it.
I have to finagle it because I've got 3 to the or 3x right here, which is just going to be 3, but I've got a 5 right there. So if I want to change that 5 to a 3, what has to go out here?
3/5.
Other way.
5/3.
5/3.
Close enough. At least I'm talking. Cough, cough, Hannah. Cough, cough.
You can cough at Hannah all day long, okay?
Yeah.
There you go. See? So this becomes 5/3.
I feel like I'm stupid because I actually say something and then they're like, "Oh, I know it."
Oh my gosh, in this box though, there's only like 4 of these. And so I like, it's kind of embarrassing because like I talk and stuff, answer questions, and then sometimes I get it wrong, and I'll get like multiple questions in a row wrong. She'll
But
like,
at least you're
"No."
speaking.
Yeah.
Yeah.
I mean, you're right, but
He's straining him.
All right. Oh, wait, that's a negative 1/2. Tiny little negative right there. I tried this thing where I stand up more because it's like supposed to be healthier or whatever. But when you're trying to write, I don't know about you, like I have to get close to the paper to write. So I'm just like a hunchback.
you need to get one of
Quasimodo
those
up here teaching class.
standing desks.
I do. I've talked to Brandon about getting a standing desk, but and one of those things that you actually stand on because my feet hurt. Okay, so
Just get some orthopedic.
I'm gonna come in with like the grandma shoes. What are those SAS shoes that grandmas wear?
Have you seen Alexis's shoes?
No.
Alexis Williams, she has some grandpa shoes.
Today?
No, I don't know today, but
Oh.
they're white and they're like New Balance, like
Oh, I love it. She gonna go out and mow the yard in them this summer.
Yeah, what it looks like. Like, oh,
I need my ear to pop. All right, so this is close, right? So this is gonna end up, if I took the derivative of that, it's gonna end up being 4x. Well, I got a 3x, so I feel like there's some stuff I could do. So if I change this to 4x and then leave this like it is, how about I actually write that 3 instead of just plus nothing?
that's a syntax error.
Yeah. What needs to go right here so that when I multiply it, it still is actually 3x?
3/4.
Yay! I think we figured it out. We figured out
Now,
multiplication.
after this, I don't know. Like after this step, I get lost.
Okay. So then you don't get lost. So that would be 3/4. This stays just like it is, except I add 1. So what's a negative 1/2 plus 1? It's a positive 1/2. Dividing by 1/2 is the same thing as multiplying by what? 2 plus c. 2 times 3/4 is 3/2.
I'm just glad we don't really have to simplify.
All right, this is it. Use substitution. That's what this is called. So, in each of the 8 examples above, the g prime of x or the license to integrate existed in the integrand we got it by multiplying by a constant. The g prime does not always exist, and there are times when it is not attainable by multiplication of a constant. So look at this one here. What is the inner function? 2x minus 1. And so then what would g prime be?
2.
Is g prime of x part of the integrand? No, it's not. See, 2 is not part of that anywhere. And because it might be that blinds guy, he may not be done, because that's what it sounded like all day yesterday when they were putting blinds upstairs. Because he's got this big cart, and then he has all those metal blinds on it, and so it makes a lot of noise rolling it back and forth.
I like the blinds.
Yeah, I do too. And it's really good because, like, 8th period, nobody can sit at that desk because the sun is so bright coming in. You can't sit there. It's miserable. So, and then like Miss Hart, she has her desk in that north corner of her room, so she can't even sit at her desk in the afternoons. So it's gonna work out. All right. Anyway, so is g prime of x attainable by multiplying the integrand by a constant? No, it's not, because
There's an X.
yeah, because there's an x there. You would have to do 2 over x, and that's not a constant.
2 over X.
Not a constant. So in this case, you have to use this method called U substitution. Here's how it works. And U substitution is not bad. You were actually just doing U substitution, but the easy ones. These are just a little bit. So first of all, you let U be the inner function. Okay? Let U is the inner function. 2x minus 1. Sorry. So you find du. So du, 1 du would equal 2 dx.
Now, where did that come
The derivative 2
Okay.
dx, right? But you solve for dx. Okay? So I want to get this dx by itself. So what do I do to get rid of the 2? Divide. So divide by 2, divide by 2. 1/2 du equals dx. And then you find an expression for x in terms of u. So if u equals 2x minus 1, add 1, u plus 1 equals 2x, divide by 2, divide by 2, u plus 1 all over 2 equals x. So this is pretty good step-by-step for u substitution. U substitution is a big deal. So if you talk with Grant and Mason, make sure they watch this video and maybe some others on U substitution, because it's a big deal. Okay, so now you have to rewrite the entire thing, okay, in terms of U. So I'm going to rewrite the whole thing just as it is. All right, so we know what x equals, right? X equals u plus 1 over 2. Two x minus 1 is equal to u. So we're going to multiply that times u cubed. And what does dx equal now? 1/2 du. Okay. So everything is now in terms of u, right? You're like, right. Sure it is. Okay. I'm just gonna clean it up just a little bit. So I'm gonna move this. I'm gonna make that 1/2 u plus 1 u cubed 1/2 du. That 1/2 times 1/2 is 1/4. Moving it out. A little distributive property
So why did you move that out?
because I don't want it. I want to have nothing but those u's. Like I want the inside as clean as
Oh,
can
okay.
be.
It's still there, it's just not.
Yes,
Okay.
I factored it
Yeah.
pretty much because that was all multiplication, multiply, multiply, multiply. So just sort of factored it out. Okay, so now I've got 1/4 times u to the 5th over 5 plus u. Oh, that's supposed to be u to the 3rd. I just didn't write that down. So that would be 4th over 4. Remember antiderivative. You add 1 and divide. That's all I'm doing.
I was
Okay.
figuring, okay.
Yeah.
It's like, where did the
Yeah. Add 1 and divide. Add 1 and divide plus c, right? Don't forget stuff that you know because I've taught you new stuff between it. This is going back to the very beginning of antiderivatives. Okay. All right.
just hard knowing where to go from where,
I know.
where to start, and where to end.
So let's do this. That's going to be 1/20th u to the 5th, 1/16th u to the 4th plus c. This is not a definite integral, so you got to hang on to that c because you will lose a point on a free response for not having that c. Right? I can't, like that's simplified. So now I'm going to substitute back in. 2x minus 1 to the 5th, 1/16th, 2x minus 1 to the 4th plus c. And I'm done. Not multiplying that out because I don't hate myself entirely.
I mean, I do, but not enough to give us.
Okay. We got another one. So let's try this other one.
Ooh. I mean, I got the first part. The first part's easy.
Let's rewrite this like 2x plus 1 x plus 4 to the negative 1/2 dx.
So used to not using dx at all, it just being there, and now we gotta like.
Now you've got to use it like it has a purpose. Yeah. Okay, so start with the innermost function because you've got two things going on here. You've got your 2x plus 1, you've got your x plus 4. But which one is most inside? Well, that's your x plus 4. So that's u is going to be the x plus 4. U is x plus 4. Okay, I'm sitting down because this is a lot of writing and I don't want to look like a hunchback the whole time. So then you find du. So 1 du equals 1 dx. So, you know, du is dx. I just took the derivative over here. It's du. And then derivative of x is 1. So that's 1 dx. Now solve for x. Which, when you're doing this on your own, you could do this like in that same step. You don't have to do it in two separate steps, but it has to be done. So x is equal to u minus 4.
Let's not get that far yet. Let's just take it a step at a time.
Don't pull your hair out. I see what you're doing there. Don't do it. It's not worth it. Okay, so rewrite the entire thing in terms of u. So let me go ahead and just rewrite the entire thing first of all. don't have anything to replace 2x plus 1, but I do have something to replace x. So that could be 2u minus 4 plus 1. Here, let me make those in hard brackets so they're easier to see that that's all one thing right there. And then that's going to be times, now I have an x plus 4 substitute, right? U is x plus 4, so I can just put times u to the negative 1/2. And I have a dx substitute. What does dx equal? du. So then clean this up some. That's going to be 2u minus 7 times u to the negative 1/2 du. First, I would, no, I would, because remember, polynomials are a lot easier to integrate.
Oh, yeah.
So I would distribute this. So that would be, what power is that going to go to? This is to the first power. That's to the negative 1/2 power. 1/2.
You just add it, right?
Yep, because you're just adding them. Minus 7u to the negative 1/2 du. All right, now integrate it. So that's going to become 2u to the what power?
3/2
Divided by 3/2. Yeah, which is going to end up being times 2/3, but I'll write it out like that. And this is going to be 7u to the what?
2 to 1/2.
Over 1/2. Is that all I need on this line? Plus c. Okay. So this has to be flipped and multiplied. So that's going to be 4/3 u to the 3/2 minus, flip and multiply, 14u to the 1/2 plus c. Is there anything else that I can simplify in this right here? In this polynomial, can I simplify anything else? All right, then substitute it back in. 4/3. What is u? X plus 4 to the 3/2 minus 14 x plus 4 to the 1/2 plus c.
And we're not gonna.
We're not multiplying that out. No, we are not.
So they'll accept that answer. If it's a free response, they'll accept
Yes, you're
that
done.
answer. Okay.
Walk away from that ugly thing. Just be like, getting all the negativity out of my life, and you are one of them. I'm leaving. So there you go. I don't think that we have time to finish this one, but let's see if we can find a u, a du, all that, okay? So what's your innermost, and by the way, this is definite, so that's even a little bit different, but it's not too bad. What's your innermost function
Just leave
here?
off the C, right? On the- Kind of.
Kind of.
Well, you do like the minus thing.
Yeah.
But 2x plus 1 is equal.
2x plus 1, okay. And so du would be what?
Two
2dx. Okay, so remember you want to solve for dx. So 1/2 du would equal dx. And then, so if u is 2x minus 1, it just kills me to say u is, but u is 2x minus 1, then what's x?
U minus 1 all over 2.
Okay. Or you could say 1/2 of u minus 1 equals x if you wanted to. Okay. All right, we're going to stop there because you have to do something with those endpoints that we're not going to get into right now. Bye, Mason and Grant. Have fun with this.